Hello friends, welcome to Learner's Planet. Friends, this is our second session for basic algebraic concepts and terminologies. In the previous session, we have discussed so many algebraic identities. We discussed various type of linear equations. We discussed some basics of exponents. In this session, we'll be discussing quadratic equation and some more concepts related to algebra. Okay, so let's begin this session. Now let's see quadratic equations. Now what's a quadratic equation? As we saw, linear equation, there is a single solution for the variable. In quadratic equation, we have two solutions for the variable, right? And it's a quadratic equation, that means an equation with second power of the variable. The format is ax square plus bx plus c is equal to 0. Here a, b, c are constant and x is variable. Now you can very well see the highest power of x is 2. That means it is a quadratic equation. That means there will be two values of x which will satisfy this equation. Okay, so that's quadratic equation. Okay, now suppose I have an equation. I take an example, x minus a x minus b is equal to 0, right? This is what a quadratic equation. Why it is quadratic? Because I'll be getting two values of x. How? This is equal to 0 or this is equal to 0. That means if product of two term is 0, that means at least one of them must be 0. So either this is 0 or this is 0 or both of them. Okay, so if it is 0, so x minus a is 0, x is equal to a. Or if it is 0, x minus b is equal to 0, x is equal to b. So we have two solutions for x, that is a or b, right? So two values of a satisfy this equation. That means it is a quadratic equation. That means this equation has two solutions, a and b. Okay, so this is why we call it as a quadratic equation, because we have two solutions for the variable. Okay, now friends, we discuss about the expansion of quadratic equation. As I told, x minus a into x minus b is equal to 0. If we multiply these two terms, what we will be getting? X square minus a plus bx plus ab is equal to 0, right? See, solution of this equation were a and b. These are called solutions or roots, whatever you can say. The solution of the equation or roots of the equation. Now you just relate this roots to this equation, right? Roots of this equation is a and b. Coefficient of x is minus of a plus b. That means what we can say, x square minus sum of roots into x, right? That means sum of the roots in negative. Okay, sum of the root in negative, then x plus product of the roots, isn't it? Okay, suppose I have say equation x minus 3 x minus 5 is equal to 0. So directly I can write the expansion of this. X square minus roots of this equation are 3 and 5, because x is equal to 3, if you put it will be 0, x is equal to 5, if you put it will be 0. So roots are 3 and 5, right? So sum of the roots will be 8. So x square minus 8x plus product of the roots 15. So this is the expansion of this equation. So if you have this, you can get this. If you have this, you can get this very easily. Okay, so precisely the expansion, or we can say a quadratic equation, coefficient of x is sum of the roots in negative and constant term is product of the roots. This is product of the roots, that is the constant term. Okay, so if we take any general equation, say ax square plus bx plus c is equal to 0. Keeping the coefficient of x square as 1, what I do this, right? Now what is x? What is b by a? That is sum of the roots in negative, that is this. So sum of the roots, suppose roots of this equation are alpha and beta. That means alpha plus beta, that is sum of the roots, that's coefficient of x in negative. Okay, product of the roots, alpha beta, that is constant term. Okay, so if you have the equation, you can get the roots. If you have the roots, you can get the equation. Okay, so we have just discussed a quadratic equation, ax square plus bx plus c is equal to 0 with roots or solutions as alpha beta, right? Now looking at the quadratic equation, we directly cannot conclude the type of roots, or we can say nature of roots, right? So how do we say what will be the nature of roots? For that we need to follow certain steps. So here I just write down the steps for you. See, uh, the solution of this quadratic equation are alpha and beta. That's given by, there will be two solutions. It's given by minus b plus minus b square minus 4ac by 2. Right? Here b is coefficient of x, a is coefficient of x square, c is the constant term. Minus b plus minus b square minus 4ac by 2ac. That is the formula for calculating the values of alpha and beta. Alpha and beta are two roots or two solutions of this equation. So one solution you will be getting by plus sign and other solution you will be getting by the minus sign. Right? Suppose I have the equation x square minus 5x plus 6 is equal to 0. So if I have to find out the roots of this equation, easily I can put up the value of a, b, c by comparing with this equation. I can get both the roots. Now how? So if I compare these two, a is what? 1, b is what? Minus 5, and c is what? 6. Right? Just put up the value of a, b, c over here. So it's minus of b, so minus of minus 5, it is 5, plus minus b square, that's 25, minus 4ac, 4 into 1 into 6, that's 24, by 2a. It's not c, it's only 2a, so 2, right? So that is 25 minus 24, that's 1. So square root of 1 will be 1 because we already have taken plus minus. So 5 plus minus 1 by 2. So 5 plus 1 by 2, that is 3, and 5 minus 1, that's 4 by 2, that's 2. That means 3 and 2 are the two values of x which will satisfy this equation. That means if you put x is 3, then also you will get 0. If you put x is equal to 2, then also you will get 0, right? So the two solutions of this equations are 3 and 2. So by putting the ABC in this formula, we can get the values of the roots. Okay, now but we discuss the nature of the roots in detail. Now what's exactly I'm talking about the nature of the roots. See here, the roots or the solution that you can see is 3 and 2. These are actually rational numbers, right? So which type of numbers or which type of roots will be there, that for that we discuss the concept nature of the roots. So my equation ax square plus bx plus c is equal to 0. Roots are alpha and beta. The values of the roots can be obtained by this formula, right? Now nature of roots. Nature of roots depend upon this b square minus 4ac. Now how it is dependent on this? Nature of the roots, that means that roots are rational, irrational, whatever, real, not real, that we have to see. Now it depends upon b square minus 4ac. Now b square minus 4ac may take any value, right? So the three possibilities which I am discussing over here is b square minus 4ac is equal to 0. Now if b square minus 4ac is equal to 0, then what would happen? This plus minus will be meaningless because you'll be having 0 over here, right? So in that case, what would happen? For alpha, the value will be minus 2 by a. For beta, the value will be minus b by 2a. That means alpha will be equal to beta. That means both the roots will be equal. Okay. So if b square minus 4ac is equal to 0, roots of equation will be equal. Okay. Second thing, if b square minus 4ac is not equal to 0, then two cases may arise. B square minus 4ac is greater than 0. Right? Now, if further b square minus 4ac is greater than 0, then further two cases will be there. B square minus 4ac is perfect square or not perfect square. Okay. If it is a perfect square, it will come out of the square root. So you'll be getting rational solutions, rational roots. If it is not a perfect square, then you'll be getting two roots are irrational. Okay. Suppose b square minus 4ac is 9, then you'll be getting plus minus 3. Right? So you'll be getting rational roots because this is rational, this is rational. So the roots will be rational only. But if b square minus 4ac is a not perfect square, so that won't come out of the square root. Suppose it is say 15. Now 15 will not come out of the square root. So what you'll be getting? Minus b plus minus root 15 by 2a. So that will be an irrational quantity. That means both the roots will be irrational. Okay. So if b square minus 4ac is greater than 0, the roots, the two cases, one is perfect square, not perfect square. If the b square minus 4ac perfect square, roots will be rational. If not perfect square, irrational. Okay. And the third case is when b square minus 4ac is less than 0. Now less than 0 means what? B square minus 4ac will be negative. If it is negative, so a term under square root, if it is negative, we call it as complex number or imaginary number. Okay. This is the square root. If the term under this is negative, that means it's not real, it is imaginary. Okay. So if b square minus 4ac is less than 0, the roots will be imaginary or we can say complex. Okay, so the three situations we have discussed, b square minus 4ac is equal to 0. That means b square is equal to 4ac. That means both the roots of the equation will be equal. If b square minus 4ac is greater than 0, there are two situations, perfect square or not perfect square. If the b square minus 4ac is perfect square, the roots will be rational. If b square minus 4ac is not perfect square, then the roots will be irrational. But in this, both the case, the roots will be real only. Okay, the roots will be not real or imaginary or complex in only this case when b square minus 4ac is less than 0, right? So the objective based questions can be framed very easily on all these concepts, right? So you need to be clear, if b square minus 4ac is 0, roots will be real and equal. If b square minus 4ac is greater than 0, then roots will be real definitely. Rational or irrational, that's a different thing. If b square minus 4ac is less than 0, the roots will be imaginary. So the three things should be very much cleared in your mind. Okay. Now, the three situations which I have discussed just now can be graphically presented. Now, how can I present them graphically? Just wait for me. See friends, a quadratic equation, whether it is ax square plus bx plus c is equal to 0 format, or directly if we write x minus say a, x minus b is equal to 0 format, whatever the format is. The difference between these two, in this case x square coefficient is there, in this case x square coefficient is 1, in this case x square coefficient is not 1, right? So in both the cases, since I have already told you a quadratic equation represents a quadratic equation has two solutions, right? Now these two solutions, we discussed three cases, b square minus 4ac is 0, b square minus 4ac is greater than 0, and b square minus 4ac is less than 0. Now listen to me carefully. Every quadratic equation represents a parabola, right? So this is a parabola. Okay, so this is the representation of a quadratic equation. This case, we can see this and this. The parabola is passing through x-axis, right? So if we take this case, both the cases are same except the coefficient of x square. For simplicity, I am explaining this case. So this is A and B. This is the point A and this is the point B. That means when x is equal to A, right? When you put x is equal to A, y will be 0. Suppose this is actually x minus A, x minus B, right? This is quadratic expression, not equation. So if x is equal to A, then y will be 0. If you put x is equal to B, still y is equal to 0, right? So the parabola is passing through 2 points A and B, right? So that means this equation has two solutions, A and B. Okay, in that case what is happening? B square minus 4AC is greater than 0. Okay, do not get confused between this AB and this AB. I just change the variable for your simplicity. I write them x minus L, x minus M, right? L, M, right? Do not get confused. L, M, right? So the solution of this equation is L and M. In that case, B square minus 4AC is not equal to 0, is greater than 0. Okay, so if B square minus 4AC greater than 0, you will be getting two solution of the equation. That's this point and this point. Okay, next thing is, if I can give you the example of that. Suppose x minus 2 into x minus 3 is 0. So the curve will intersect x-axis at 2 points, 2 and 3, right? Similarly, if x minus 2, x plus 3 is equal to 0, then the curve will intersect at 2 and minus 3. Okay? Next pattern is when both the roots are equal. That means b square minus 4ac is equal to 0. That means b square is equal to 4ac. Both the roots are equal. Suppose I have x minus 2 whole square. So what's that? X minus 2 is 0. That means 2 is the only value that will satisfy this equation. When you put x is equal to 2, this expression will be 0, right? So this will be like this. The parabola will touch x-axis, right? In this case, the parabola was intersecting x-axis at 2 points when b square minus 4ac is greater than 0. In this case, the parabola is touching x-axis only at 1 point, that is x is equal to 2, right? So graphical representation should also be clear in your mind. Okay. Now the third case, when b square minus 4ac is less than 0, right? Suppose I have equation x square plus 2x plus 8, right? This is the equation. If you try to find out the value of x that makes this equation as 0, you won't be able, right? Why? Because b square minus 4ac is less than 0, right? I just show you how it is happening. It's minus b square minus 4ac, that means coefficient of x is b, that's 4 minus 4 into a is 1 and c is 8. Okay, so 4 minus 32, that's minus 28. Okay, so that's less than 0. That means b square minus 4ac is less than 0. So this expression minus 28 will not be able to come out of the square root. So you'll be getting unreal or imaginary roots, right? So the graphical representation is no value of x. Suppose this expression is y. Do not get confused between an expression and equation. Equation when this is equal to 0. Expression when y is equal to this expression. Okay, so no value of x would make this expression as 0. Okay, so the graph will be like this. Okay, it won't touch, it won't intersect x-axis. No touch, no intersection. Okay, so you don't have any value of x that would make this expression as 0, or you cannot get the value of y as 0. That means it is never equal to 0. Okay, for any real x, obviously. So friends, we have discussed linear equations. We discussed 3 cases, and in quadratic equation we discussed 3 cases, right? Do revise this session So, and we will be taking problems based on algebraic concepts in our next session, right? So once you are clear about the basics, it will be easy for you to attempt the problems and understand the problems. Okay, so I'll see you in the next session once again. Bye bye.